Alright, just think, up till now you didn't know what a dependent and independent variable were, but now you're going to be able to identify those in equations and in graphs. It's a big day. So lesson 6.ee.9. Your vocabulary obviously should be dependent variable and independent variable. You already know what a variable is. It's a symbol that stands for a number. It's usually a letter. So, the dependent variable is a variable whose value depends on another variable. That's why they call it dependent. It's usually the number that you're looking for, that you're trying to figure out. So the independent variable is a variable whose value causes another value to change. Okay? So when you change the independent variable, it changes the dependent variable. So in an equation, they're pretty easy to spot. The dependent variable is usually by itself. The independent variable is usually in an expression. Okay? So I'm going to say that again. The dependent variable, that y right there, the one that's all by itself, that depends on what the x is. So the x is independent. Okay? The y is determined by whatever the x is. So in other words, in this case, if you put in a 1 where the x is, y is 5. If you put a 2 where the x is, y would equal 7. The y depends on what you put in where the x is. That's why it's called dependent and independent variables. Okay? Alright. If you're looking at a graph, you need to be able to identify the where the independent and dependent variables are. So a graph will show the relationship between two variables. That's what a graph is for. That's what a coordinate grid is for. This graph we're looking at here is showing the relationship between weight and price, and they're calling the price R. Okay? So, do you think that the price depends on how much something weighs, or the weight of something depends on how much it costs? Let's think about that. Do you think that if you're buying something like a grape, if you raise the price of the grape, does it make it weigh more? No. The grape does not get bigger because you raise the price. But if you buy more grapes, does it cost more? Yes. So the weight determines the price. So the price is dependent and the weight is independent. So you're always going to find the dependent variable on the y-axis, on the up and down axis, the vertical axis. The independent variable will always be on the horizontal axis, which is the x-axis. Okay? So for the most part, if you see a y, it's usually the dependent variable. If you see an x, it's usually the independent variable. In science class, when you go to graph things, the independent variable will always go on the x-axis, on the across axis. The dependent variable will always go on the y-axis. Moving on. To figure out which variable is the dependent and which is the independent variable, you're going to do the following. Now remember, these are our notes. So we should be writing these down. So, to figure out which one's which, first, decide which variable affects the other. So the independent variable, if it affects the independent variable is the one that affects the other. And decide which one gets affected. That's the dependent variable. So which one is changing the other one? Okay? The one that does the changing is the independent. The one that gets changed is the dependent. With an equation, the dependent variable is usually alone. on one side of the equal sign. And the independent, spelled wrong, is in an expression on the other side. So, once again, y equals negative 4x minus 7. We've got two variables here, the x and the y. So, the y is alone. That means that the y is dependent on what the x is. The x is in an expression on the other side, so the x is independent. Okay? You may have to refer back to these notes a little bit. So, with a graph, the independent variable is on the x-axis, the across, and the dependent variable is on the y-axis. So if you're looking at a graph, it's pretty easy to determine which one's independent and which one's dependent. Whatever the x-axis is independent. Independent variables on the x-axis. Whichever one's on the y-axis is dependent. The dependent variable is on the y-axis, so it would be written right there. Okay, so here's an example. At Food Mart, grapes cost $4 per pound. What is the dependent variable and what is the independent variable? If this was an equation, we would say the cost of the grapes equals $4 times the pounds. Okay? So if it was 7 pounds, if you bought 7 pounds of grapes, you would do 7 times 4, and that would be the $28 total cost. So if you're writing an equation, you want to use variables, so we'll let cost equal C and pounds equal P. So the cost equals 4P. Remember, dependent is alone, and independent is in an expression. Okay? The cost depends on the weight. The weight doesn't depend on the cost. If you raise the cost, it doesn't change the weight. Okay? If we were to put that on a graph, you want the dependent variable on the y-axis. So you'd want the cost, writing sideways isn't my forte here, you want the cost on the y-axis and you want the weight on the x-axis, because the weight is independent and the cost is dependent. So in other words, if you bought 0 pounds, it would cost you $0, so the dot would go on 0, 0. If you bought 1 pound, it's going to cost you $4. If you bought 2 pounds, it's going to be 8. If you bought 3 pounds, it's going to be 12. If you bought 4 pounds, it would be 16, which is above the lines there. So that's showing you the relationship. And we've talked a little bit before about linear equations. This is a linear equation. You can see it right through here. If you draw a line through the dots, it makes a straight line, straight-ish line. Okay, so once again, the weight is independent and the cost is dependent. Here's some extra examples. Don't put these in your notes. Consider this graph. I am considering it. Okay. Done. I considered it. Select all the statements that are true about the relationship between the independent variable and the dependent variable. Remember, independent and dependent. First situation. The dependent variable is 4 times the independent variable. Dependent variable is 4 times. This is exactly like the cost of grapes graph, and that is true. The dependent variable, the side, like the ordered pair for B, that's 4 whatever, and that is dependent on the 1. So the ordered pair for this is 1, 4. So the independent variable is the first part of the ordered pair, and the dependent variable is the second part. So yes, The dependent variable is 4 times the independent variable because each y value is 4 times greater than its corresponding x value. Correct. Okay. I need to turn this size. I hope this records accurately when I turn my iPad. The independent variable, right here, the independent variable is 4 times the dependent variable. Well, no, we just said it the other way around. So, no, it is not. The dependent variable is 1/4 the independent variable. The dependent variable is not 1/4. The dependent variable is 4 times the independent variable. So, no. The independent variable is 1/4. So, the numbers across the bottom are 1/4 of the numbers on the sides when you look at the ordered pairs? Yes. For point C, the number across the bottom that it corresponds to is 2, and that's 1/4 of the number on the side that it corresponds to, 8. So the independent variable is 1/4 of the dependent variable. Yes, that is correct. Moving on. Robin recorded the amount of money she earned over time. The table shows the results, his results. Okay, so Robin's a boy. It could be either male or female, that name, but in this case, Robin is like Batman and Robin. It's a boy. So we need to know which equation represents the amount of money that Robin earns after any number of hours that she works. Oh, sorry. Now wait a minute. I think I see an error here. Check it out. They're trying to mess me up. First, it says that Robin recorded the amount of money she earned, and the table shows his results. So what is it? He or she? That's confusing. I don't think I want to think about that too long. Okay, so regardless of whether Robin is a boy or a girl, let's look at the graph. Now we've done some of this writing equations from tables. So the first thing you do is you look at the increase. From $16.50 to $24.75 is an increase of $8.25. Now when you look at the independent variables, they're going up by 1 each time, so that's good. So that makes it easy. We just look for that increase, and so I know that the y is going to equal that increase times x, and I may have to add or subtract to adjust it, but when I look at these numbers, 2 times 825 is 1650, 3 times 825 is 2475, so this is the equation. Y equals 8.25x, right there. Okay, remember, you multiply the increase by the variable. Okay, next one, part 1. In the following table, the value of y depends on x, okay? Just like usual. Complete the table with the correct values. Okay, these are obviously going up by 8 each time. Okay, so in any linear pattern, the increase has to always be the same. So it's going up by 8 each time. That means that the y is going to equal 8x. So 8 times 7 is 56. 8 times 8 is 64. 8 times 9 is 72. It's going up by 8 each time. Write the equation that represents the relationship. Y equals 8x. No problem. Time for the quick check. You can read it. See you soon.